Well, good afternoon, everybody, and welcome to the Royal Astronomical Society. How many of you have been here before? Oh, most of you, right. So I just want to welcome you to, on this rather gloomy afternoon to the Royal Astronomical Society. Introduce myself first. I'm Philip Diamond, and I'm the Executive Director here at the Royal Astronomical Society. It gives me great pleasure to be able to introduce my Deputy Executive Director, Robert Massey, Dr. Robert Massey, who has been at the RAS for many years, more years than he probably cares to remember. But Robert has a PhD in astronomy from Manchester University, and then he moved into teaching, which he did on the South Coast, I believe, and has been involved in council politics in London as well, then became a public astronomer at the Royal Observatory Greenwich. And combining all those skills, he then joined us some years ago at the Royal Astronomical Society as a press officer, I believe, before my time. But has since moved up the hierarchy at the RAS, and amongst his many responsibilities, he has public policy and communications in his remit, and does a very effective job. So I'm very, very pleased to introduce him today, and he is going to be talking about what's going on in our skies to stop us looking up and observing and doing our wondering at the joys of the night sky. And he's going to talk about the science of that, but also the public policy about what we might all be doing to try and ensure that that young astronomers are inspired in the night sky and they don't see lots of tiny comms satellites floating around whilst they're looking up. So without further ado, let me introduce Robert, and I'm sure this will be a fascinating lecture. Thank you.
Thank you, Phil. And thank you. Thank you to everybody for coming as well. And it's bad to start a talk with an apology, but I think I do apologize for the temperature of the room, which is a bit lower than we'd like. So hence the closed doors. And hopefully the 70 watts or so that each of you emit will warm up the lecture theatre over the course of the next hour or so. But anyway, as Phil said, what I'm going to talk about today over the next 40 minutes or so is this cluttered and noisy sky, the thing that some of you, but not all of you might be aware of, which is the advent of the era of what are, sometimes referred to as mega-constellations, mass constellations of not stars, but satellites in the sky, and specifically in low Earth orbit, and why you should care about it, or perhaps I need to persuade you to care about it. But the point is, I want to tell you about their impact, what we're trying to do to mitigate the problem, and some of the other side issues around that you might not have thought about. So I hope that, if you've come to this talk here, and I hope that you value views, if not like this, maybe even better, views of a pristine night sky, which clearly we don't often get in central London or ever get in central London. But if we go out to the darker places in the UK and around the world, we can enjoy that. It is possible to travel to places and see many, many more stars than you do with your eye alone in the center of our cities. So this is, one of the many images you can find online showing the kind of thing I'm referring to. Not as festooned as some are. If you look at some of the Milky Way and so on, they're even more dramatic. And classically, what we tend to be concerned about is the effect of terrestrial light pollution. So lights and street lights and advertising hoardings, sports grounds, all those kind of things that, diminish the view somewhat. But in recent years, particularly, there's been more concern about a secondary problem, which is specifically the impact of satellites on that view. So to remind you, a satellite is, this is a very simple schematic, obviously, but a satellite is essentially something, in this context, an artificial satellite going around the Earth. There are some that go around other bodies, including Mars and so on, but they're vanishing in small number compared with the ones going around the Earth. And the idea comes actually as far back as the 17th century. Isaac Newton had a kind of thought experiment where he sat there and he thought, well, if you fired a cannonball off a very, very high mountain, aggressively further with the more force and energy you launched it with, until at some point it would be going so quickly that the rate at which it fell to Earth would more or less match the curvature of the Earth. So with the other caveat of not having an atmosphere to impede it and presumably removing the original mountain out of the way so it didn't come back and collide with it, it would be possible for that satellite to make circular orbits or orbits of a different kind around the Earth. So that's essentially what a satellite is. The reason they don't fall to Earth is because they're moving quickly enough that the Earth is moving away beneath them as they curve round under the influence of gravity. It's not fair to say that they're not feeling the gravitational effect of the force of the Earth. That's what keeps them in place. So, I would be the first to agree that launching things into space, that satellites have brought enormous benefits to us. I would remind you that we've had them in orbit since the 1950s, Sputnik 1, which obviously was the Soviet Union's first model there. These are all obviously flight spare copies and so on, rather than pictures of the satellites in orbit. There was simply no way of taking pictures of them at that time. So the Soviet Union started the so-called space age by doing that. And then Explorer 1 came for the United States a few months later. At that time, there was huge political pressure between the superpowers, political rivalry between the superpowers to make this happen. And although it was probably not fair, not realistic at all, Sputnik was enough of a kind of public scare for the American public to help drive that forward, and was certainly capitalized on by NASA and others to secure funding and support for their programs. And then on the right, because we're in the UK, there's Ariel 1, which was one of the first UK satellites. It was actually a communications one, and I believe was one was destroyed in a nuclear test. Actually, it's an interesting piece of history. There have been very few tests in Earth orbit, but one of them destroyed this satellite. So, fortunately, they're banned now, which is not a bad thing at all. But as I said, they play a crucial role. They actually help us in everyday life in very, very many different ways that we're not always aware of. Communications, clearly, some of the earliest ones were responsible for things like transatlantic TV broadcasts that hadn't been possible before. Weather, very obviously. The ability, you can't overstate how significant it is to be able to look down on things like weather systems from above and understand them. Earth observation more generally, whether that's looking at things like the thickness of the ice caps or oceans and so on. Geophysics in the same way as well, understanding the magnetic field of the Earth, looking at things like seismic and volcanic activity, general environmental change, obviously, climate change and so on, measuring CO2 levels, all those kind of things are possible. Astronomy, I should say at the outset, it's been a huge boon to astronomy to place satellites in orbit because they're above the atmosphere, and that means we can observe the universe at wavelengths that isn't possible from the ground, ultraviolet, X-rays, and so on. And espionage as well. Ironically, actually, the espionage, the spy satellites of the 1980s are now pretty much as good as the equivalent views to that you get from Google Maps, by the way, if you look at Google Earth. But they're still incredibly important. And obviously navigation, if you drive a car and use a sat nav, or you get in an aircraft, then, this is part of the global navigation system. The different countries and different bodies operate. So, as I said, I recognize very much that they have a huge value. But interestingly, even if you go back 60 years, you discover that astronomers have complained a little bit about this kind of thing from the outset. So right back in 1961, the Americans had the idea of something called Project West Forward, launching 480 million little copper needles dipole antennae into Earth orbit to provide a kind of artificial ionosphere. And the idea was that you would use that instead of the ionosphere is a layer in the Earth's atmosphere that you can bounce radio signals off. It's ionized, and hence the name. But sometimes it's not there as well. So their idea was you could have this artificial one in orbit. Now, very quickly, there were actually protests from astronomers at that time about what this would do, including from, in the UK, but also in the Soviet Union as well. So they lined up on this, saying it was a kind of piece of vandalism. And you can see, not expecting you to read the whole thing, but you can see that the council of this body, the Royal Astronomical Society, complained to the US about it and said that it would be shutting off radio astronomy because it would interfere with those signals that were coming from further out in the universe. So right back more than 60 years ago, we've had some awareness that satellites in orbit present an issue for astronomy on the ground. And Francis Graham Smith, who's now actually approaching his 100th birthday, we're going to put a note up on that on our website soon. He was Astronomer Royal back then. And in 1980, he noted as well that if you had more and more satellites, that it would start to become an issue for optical astronomy. I want to ask a question in passing. How many of you have seen the International Space Station above our head? Yeah. A large number of people. It's really obvious and bright, and you can look up when it's visible. If you see this very quiet, bright dot moving across the sky, chances are that's the International Space Station. The distinction with an aircraft is there won't be flashing lights and it'll be completely silent. So yeah, we have been aware of this for a long time. And another thing to understand is that satellites operate in different regions with fairly arbitrary definitions, depending on their altitude. Again, I don't expect you to read the details. The lettering's far too small, but broadly, you've got LEO, which is low Earth orbit, MEO, so the medium layers of Earth orbit, GEO, which is geostationary or geosynchronous Earth orbit, and then high Earth orbit, which is more for some scientific missions. Now, the significance of those is that the low Earth orbit ones tend to be things studying things on the ground. The ones in the intermediate space are things like sat-nav, actually. At the higher level of geosynchronous, that means they stay above the same spot on Earth, actually somewhere above the equator, and you can use them to send signals around the world. That was the original intention there. And then, as I mentioned, the higher ones are done for exploration as well. So there are different domains here too. As you would expect as well, the higher they are, the longer they take to come down. The very high altitudes, they essentially never will. Low Earth orbit satellites will eventually decay because there's some of the Earth's atmosphere fading out. So they run into it, and over time, they lose energy and they burn up in the Earth's atmosphere. So if you were to go back few years, so in the late 2010s, we still had concerns about the number of satellites in orbit and how they were being managed. One of the biggest ones was around space debris, because if you have a lot of satellites, then any single kind of collision between them generates a lot of debris. There have also historically been things like anti-satellite tests. It's actually forbidden to do those kind of things against another state in orbit. There's a UN treaty governing it. But the Russians, the Chinese, and the Americans at different points have all tried this, destroying their own satellites, and it creates a big cloud of debris. So we worried about that because it damages the satellites that are functioning. And the more there are, the harder it is to manage. And there are also trivial things like dropped tools and bolts and bits of rockets and so on that are going around the Earth as well, that we have no means of controlling, and only the largest ones we can track. But the crucial thing to note is that 4 years ago, there were about 2,000 active satellites in that region of space. And already in the last 4 years, we've added roughly another 4,200 or so to that total. So it's more than doubled in that time. We are now in a region, we're now in a kind of, it's best to describe it, I think, as a paradigm shift where the large scale exploitation of that region of space is underway. And we may, it's really hard to say whether this will happen, but we'll certainly see, I think, tens of thousands of satellites. At the higher estimate, we might have hundreds of thousands or even towards 1 million satellites in that domain. It just depends on how feasible the business cases are for the different companies that want to do it. So it's a real shift in how we're doing it. Another way of looking at it is this graph here. This is from a paper by Andy Lawrence earlier this year. And again, you look at the number of tracked space objects, and you can see, incidentally, whenever you get things like a weapons test, you get a big step up, okay, because they smash a satellite and you get more and more objects added to the debris. The debris total rises. That's the uncontrollable stuff, obviously. Leftovers is a great term, isn't it? But dead satellites and also active ones, the blue line there is rising rapidly as well. So all of these numbers are going up. Sometimes you might hear about something called the Kessler syndrome, which is the idea that you get a collision and the debris cloud becomes so big that it then is self-sustaining. You get a kind of chain reaction of destruction. So who are the big actors in all of this? Well, one of them is SpaceX. And you'll be aware, obviously, of Elon Musk, and failed to actually make a launch yesterday. I think they were doing another attempt today, weren't they, to try out the Starship vehicle. But one of the other things SpaceX is doing, apart from Elon Musk running Twitter and Tesla and so on, he has this company too, is launching this Starlink system with the explicit purpose of delivering global internet access, which, as astronomers, we're not going to argue that that's a bad thing inherently. We just want this to be managed properly. But it does mean a big change. So the first phase, which is pretty much complete, is 3,000 satellites. And the next phase will be another 30,000. And actually, that's partly been blocked, partly down to the work of us and others in writing to the licensing body in the US, just to try and stop it. They often show this picture here because at the bottom, you don't see all of it. Some of it's restricted, but there are animations. They show essentially the satellites peeling off into orbit because they launch tens of them each time to build this constellation up. And the aim of this is that they cover the Earth and they send signals down to base stations that you can buy for several $100s, actually. It's not terribly cheap. And then you subscribe to it as you would any other internet provider. I don't think it has, the only thing I would say is I don't think it has quite the largesse that's implied sometimes, because if you live in, say, sub-Saharan Africa, it's very expensive compared with your income. But there are other providers too. The only other, well, there are a couple of others that are seriously getting underway with this. One is OneWeb, which is slightly notoriously bought by the UK government in part. It's also owned by Bharti Global, an Indian conglomerate, and others. They have about 650 satellites working, doing the same kind of thing. There's a picture of a flight spare there. And then also, that gives us some responsibility, I would argue, in the UK, though, because we own one of them. And also AST, which is another operator which wants to do satellite communication to your mobile phone. And these are controversial because they're potentially, well, they are very, very big. I mean, the deployed satellites may be as big as tennis courts and maybe a couple hundred of those. So they put up their prototypes already. They had some connections in the UK as well, but I don't think they do now. There's also in Europe, the EU has a proposal for a constellation, 7 billion euros. That's again has the same idea of tackling internet dead zones. I should say, by the way, though, that because I haven't included this on the slides later, we've had some success in persuading the EU to modify their designs, as we have with some of the other countries. But there's still work to do. But they're quite sympathetic to making sure astronomy is possible. Okay, so what impact does it have? Well, we look at the universe basically with the electromagnetic spectrum. Okay, so we use light and radio waves and all the other parts of that to understand things that are further out. And as well as these satellites, we have observatories in orbit too, on the ground, like the one up there. Sorry, the one down there is Hubble, which is the famous one. And obviously you've got James Webb, which is a lot further out. I should stress that JWST is not affected by this because it's so far from the Earth that it's not there, although you can envisage a time when it gets harder to place things there going through this, this busy traffic lane around the Earth. But Hubble definitely is, and then the observatories on the ground are too. And classically, the way we make them work to best effect is to escape the influence of light pollution and radio pollution, which I'll come to, but we do that by putting them in remote places. Now, that might be, say, in the high mountains of Chile, or it might be above the surface of the Earth, way up in space, be above the atmosphere as well. And in both cases, obviously, you're improving your view of the universe through that. So Hubble operates a few hundred kilometers above the Earth, in other words, in low Earth orbit. So these observatories, anyway, these are the things we want to protect. They represent some significant investments by governments, by people like ourselves, and they deliver great science. And what we want to make sure is that that science continues to be possible. So we were obviously slightly, it's fair to say, taken aback when in 2019 we became aware of the fact, and this is, by the way, I don't think we were asleep on the job, but we certainly weren't aware of what was happening the way that we should have been. We started to see an awareness of the problem flagged up by people saying, hang on, Elon Musk is going to launch thousands of satellites. Oh, and by the way, so is OneWeb. And people started to create images showing what happens when these bright satellites pass through astronomical frames. Now, they're slightly constructed. At the first images, you had to know where the satellites were and so on. Now it's much easier because they're everywhere. But at the outset, as well, we know where they're coming through. We'll see what they look like. And these are the kind of things that were produced. So in other words, you take something which, in this particular case, I think you've got some stars there, but mostly they're actually distant galaxies. It's not easy to tell except from the shape. And you can see that very quickly you get these streaks. Because if you've ever seen a satellite, what you'll know is that it appears as a fairly quickly moving dot. But, the ones that you see with your eye are obviously quite bright. And when you get a modern telescope, they make a very bright streak as they track across the field. And they're non-trivial then to remove. It's a whole different talk to explain what has to be done. So that's one example there. And then in other cases, for particular types of astronomy, it's significantly worse. So sometimes these smaller frames, they might get one or two in them. That's a bit of a problem. It can be a real problem if it goes through the object you want to look at. But if you want to study the whole sky, and there are sometimes good reasons for doing that, then it can be way worse. This one is actually only from late 2019, and it's a wide field camera for looking at meteor showers. And if you look, what you'll see is, well, you have to be familiar with what meteors look like, but the shorter streaks generally here are meteor trails. The longer things are satellites. Okay, so in other words, you've got very, very damaged data from that. It's very hard to reconstruct. And this is a particularly difficult example because if you study the whole sky for that length of time, it's really hard to do much about it. You need to have a very wide field, and that increases the number of satellites you'll see quite clearly. But it's not just confined to the ground. It's also an issue for telescopes in space as well, because unfortunately, Hubble is a bit below the altitude of many of the Starlink satellites. And as a result, many of those Hubble images, I think an estimate between 7 and 15% of them at the moment, although one might expect that to rise, are being contaminated in this way. And you can see they're really quite bright and dramatic. And that's partly because actually Hubble is a lot closer. You know, it's already several hundred kilometers up, so it's probably about 6 times closer to the satellites than we are down on the ground. And there was some great work done by some interns at ESA, actually, the European Space Agency, to understand that. So it affects all these things. And if we want to define it or to understand it, then you remember satellites are shining through reflected sunlight. So they are visible typically after twilight when the sky is dark, but before they've gone into the Earth's shadow. When they go into the Earth's shadow, they disappear from view, and that's fine. But for a lot of the night, particularly in the summer months in the UK, they're visible for a long period. And we have seen now estimates for what they're doing. It was a bit hard during the pandemic because telescopes are mothballed, but there's a lot of work gone on that. And we know that they're worse at higher latitudes, so up where we are. We also know that they're worse in the summer because basically the nights are shorter, so there's more time only just beyond twilight. And they add to that background light pollution as well, because if you have a sort of scatter of satellites in the back, then you know that lights up the general atmosphere. And the estimate is it's probably brightens the sky by about 10% or so, which is about the threshold at which we say light pollution starts to matter. So there's a good paper a couple of years ago on that, actually published in one of our journals. And it's something that, you know, if it was an observatory site, we'd be concerned about that. And also, in the long term, well, the hardest thing to know is how this changes over time, because it depends on what the companies manage to put in space, but what measures they put in place to mitigate it. But we might see a situation where 10%, possibly much higher than that, stars that we look at in a dark sky site, at least, I don't think it'll be quite true in cities, might be moving satellites. Now, that might not sound too bad, but I think I would posit the question, if you were to go outside in a dark site, look at lots of stars, and then a large number of them were moving around, I think you would argue not unreasonably that was a very compromised view of the stars, you know, that actually suddenly very distracted by that, rather than enjoying what should be a reasonably pristine starscape. We also, in terms of our science, as I said, it affects orbiting observatories, but also there are big survey telescopes planned for the next few years, like the Vera Rubin Observatory, that's supposed to study the whole sky every 3 nights or so. And that will be badly affected because it has a wide field. So think about in the twilight time, which is an important time for this telescope for doing things well, includes things like looking for near-Earth objects. Perhaps 2/5 of its frames will be affected. And there are examples already of where this has happened, not necessarily actually down to satellites, but the story on the right was in space.com. You can dig it up. And a couple of years ago, an astronomer thought they'd found a really bright gamma ray burst, which is a really very bright, distant explosion far away. Doesn't sound like I'm reading from Star Wars, but a faraway galaxy, and the formation of a black hole when you get a burst of energy. Anyway, the assumption was this was very distant and bright. Actually, it was a reflection off a dead rocket body. So it's really hard to disentangle these things and understand what's going on, or it can be. And it might just not affect things like that, but also searches for things like near-Earth objects as well. Stuff that we can't look at again. In other words, if it happens once, and it happens to coincide with the time when the satellite's there, you've lost that opportunity. Okay, if it's an explosion or a transient event, or say an asteroid passing through your field, you won't have that opportunity again, and that's why it matters. And I think, and I'll refer to this again, one of the differences is that whereas we can escape light pollution on the ground by going to a remote place, we cannot do that in this case because these satellites are designed to cover the whole of the Earth. So wherever you go, you see them because that's how they're supposed to work. So it doesn't matter where you locate yourself. And I'll return to that point again. Now, as well as optical, we have radio observatories as well, which is the other principal domain that's affected by this. These are basically like big antennae. If you imagine pointing, you know, if you have one, it seems very old fashioned, doesn't it? But if you have a sky dish and you point it out, you know, the signal comes into it, you detect something, you decode it. Essentially, that's what radio observatories are doing with astronomical objects, you know, everything from the sun and Jupiter right out to the distant universe. And that is another way of understanding what's going on around us. And these are similarly located in very remote sites. And the reason there, obviously, is you don't want people like me standing around the site with my mobile phone on, interfering with it, or taxi companies and all that kind of stuff. You know, they are deliberately protected. The famous one in the UK is at Jodrell Bank in Cheshire. And underneath there, you can see you've got this is a picture, clearly an illustration of the square kilometre array, which will be in Australia and Southern Africa. It will be huge. And both those places were chosen in parts of those countries where, you know, there are very few people and very little radio interference. However, If you have satellites whose job it is to communicate with people on the ground, then that means transmitting strong signals to Earth. And so these diagrams take a bit of explaining, but I'll do my best. So instead of detecting very sensitive radio signals, they might be affected by signals which are at least 1 billion times brighter than the kind of objects they're studying. So because, radio sources in astronomy are obviously very, very faint, you want a strong downlink signal to get your internet access to work. So on the left there is an illustration of a radio map of the sky, and that bright band you can see there, that's what the geostationary or geosynchronous satellites do already. So there's a nice band, you can see it's running across the equator, that's where they appear to be in the sky. It's hard to know exactly what all the new constellations will do, and there's data being acquired, and I imagine some of that will be presented later this year. But the simulations already say, well, look, there'll be quite a lot of loss in some bands, and it will be a much bigger problem than it is already. And the illustrations on the right are models trying to show that happening. So they are what low Earth satellites will do. Because the other difference is that these satellites that are being launched are going into low Earth orbit rather than very high up. So they are, and they have a much larger coverage of the sky. So all of this, but as I mentioned, is very, very powerful. Some of this is protected. The radio spectrum is complicated. Some of it's protected by a body called the International Telecommunications Union. Most of it isn't. That was devised, I think, in the early 60s. They put that in place to try and give radio astronomers that opportunity. They then realized that astronomers then realized they needed to look across the whole of the radio spectrum, all those bands, because the universe doesn't, adhere to human regulations in that sense. So if you want to study things, you've just got to accept that. And so they got around that by putting them in remote sites, and that's no longer going to work with satellite constellations unless we get the manufacturers to put various things in place. But it might affect a whole range of science we'd like to do. There are things like understanding the formation of stars. Actually, if you want to do it at one level, you could say trying to find ET. Trying to detect those signals from alien civilizations is harder, obviously, if you have a really noisy radio sky. But other, studying things like exploding stars, looking at galaxies other than their own, all of these things are affected badly by it. There's also an issue of just the electronics on so many satellites are not quite as well regulated as they should be, and they have their own radio interference. And the problem is when you've got hypersensitive radio observatories on Earth, they quite easily detect it. So that's another thing that actually you need to control better. And like with optical telescope, it doesn't matter where you put them in theory, unless you get the satellites to change the way they operate, everywhere on Earth is affected. Okay, there is no good site that's going to take you away from this. I should also mention, there are other side concerns around this that we've started to explore. One is the environmental impact, and I don't pretend to be an expert on this, but launching so many things, there are serious concerns about what that does to the atmosphere of the Earth. In some cases, you have very, very dirty launch vehicles that involve a lot of CO2, a lot of black carbon and so on. Even the ones that are using cleaner fuels deposit water vapor in the upper atmosphere. We're not entirely sure what that will do over time. And the re-entry, which is the way that we dispose of these objects as well, adds a lot of aluminium to the atmosphere as well. So there is a discussion about, well, we don't quite know what that does, and should the precautionary principle apply? Should we think about this before we move quite so rapidly into this new domain? And there are researchers, Moriba Jar at the University of Texas has argued we should have a sort of circular space economy, where we do actually think about the value of the resources we're placing in orbit and then disposing of them just by burning them up. Another analogy is thinking about the sea, and we no longer think it's acceptable to just dump everything in the oceans. Perhaps we shouldn't think it's acceptable to dump things in the upper atmosphere of the Earth. The value is possibly billions of rare earth elements up there. Do we really want to dispose of them quite so trivially? There are as well cultural impacts here too. And, it's not, I don't want to talk about it in totality, because obviously there are very, very many indigenous peoples around. There are very many different belief systems. But, very many of those worldview systems embody a view of the night sky and include some kind of association with that. And so there's an argument about, should people be consulted beyond just, say, commercial operators and regulatory bodies? Should we consult society more generally when we consider this? And that access, that kind of right of access to dark skies comes into that. There was the Starlight Declaration was a good example of this, saying, that it has some kind of right to that. and clearly none of us were really seriously consulted about these things. It's very much seen, I think, as just a business-only thing at the moment. So that, by the way, is another obviously great view of the Milky Way, another example of the kind of sky we'd like to keep in place. So you might ask at the moment, what is in place to control all this? Well, the answer is not very much. Okay, there's some protection of the radio spectrum. The radio spectrum is actually hugely valuable in financial terms. So I'm quite relaxed about things like 5G, but 5G became possible when analog TV switched off because the radio spectrum is crowded. So then the bands were auctioned off, and you make a lot of money, essentially. Governments make money by selling this off. In the UK, it's regulated by Ofcom. There's the Federal Communications Commission in the US, which actually also then licenses most of the satellite launches because they're done through the US. The International Telecommunications Union is then supposed to coordinate all this stuff. And they agree a very narrow bit of the radio spectrum is reserved for astronomy. So there is a little bit, but there is basically nothing protecting the sky in international law, at least not convincingly at the moment. Though, as I'll say, we are trying to make that change. So you might then say, well, what are you doing about it? And that's a very fair question. The answer is it's pretty hard, actually, but we are trying. So, acronym city at the top, but IAU is International Astronomical Union, which is the kind of global body to which the RAS is affiliated. AAS is the American Astronomical Society, the RAS is us. The EAS is the European Astronomical Society, which has really grown substantially in recent years. And we did the classic thing, I guess academics do. We expressed our concern in June 2019 and we thought, oh, this isn't good. And we and others put up statements about it. And then we fairly clunkily created some groups to try and work out what to do. I think the Americans were better at this than us at the outset, but we're catching up, but we're not bad now. And we created these groups that bring observatories and satellite operators and others together to try and thrash out the problem. Because even if we get some kind of global treaty in place, that will take many years for that regulation to get. Right now, we have to try and do this at the outset and talk to the industry players and say, we want a good night sky. So the outcomes of that so far have been pretty detailed reports and recommendations. The IAU has been good at that. It puts them into the United Nations as well, as I'll say. And we've created this Center for the Protection of Dark and Quiet Skies, and I'm an individual member of that, and the RAS is affiliated to it as well. So we are trying to work on that too. By the way, that sounds very grand. It's got, I think, the total staff involved in it is 2 at the moment, but there are various other volunteers across the astronomical community trying to work on this. You can see these reports online as well. So beyond that, we're also trying to feed into the work of the UN. The only legislative thing that really matters in space is this, the Outer Space Treaty, which is a fascinating treaty created in 1967, actually to prevent military activity in space. So after those tests, which were pretty irresponsible, the Americans did a couple of them. They did things like blew out power outlets in Hawaii and so on in the early 60s. I'm not sure which other countries did it, but they knew it had a big effect. There are many parties to that treaty. Most countries in the world are signatories in one way or another. And there are articles within it. It's not very long, articles within it which say essentially that governments authorize stuff that's done from their soil. So if the UK launches satellites from Cornwall eventually or wherever, then it is responsible for what happens. And equally, state parties, so governments, can request consultation on activities perceived or believed to be harmful. Now, the question, of course, is then at what level does protecting the night sky get seen as harm or not? And there are people working on trying to get that as a change in space, or to say that astronomy is a recognized space activity that should be covered by this. And it's under the, discussed at length quite a lot by this body, which again, you may never have heard of, the Committee on the Peaceful Uses of Outer Space, which is actually based in Vienna rather than where the main UN HQ is. And the UK put in a statement to that last year, more or less endorsing the position that we were talking about, but it's all very well to have those kind of statements. There is still no binding international framework that makes countries adhere to it. It's just still very much at the discussion stage. They've created another scientific committee to examine it, but we've still got some way to go. I mentioned this International Astronomical Union Center. That was set up last year, and it has various things that are looking at different aspects of this. I should say, because I probably haven't been fair on this, that some of the companies are actually working with the astronomical community. So SpaceX is doing that quite a lot. We might not say they're moving far enough. We might not say they're doing everything we want. That would be a bit optimistic, obviously. OneWeb do the same. They do come and talk to us about their plans. They are trying, I think, to mitigate things in such a way that's within their economic and business models. So they've tried out various things like darkening the satellites, putting visors in front of them, and now again, a different form of darkening to try to make them less visible. But it's really hard. And our fear is that, well, at the moment, we're dependent on the goodwill of some of those companies, the ones that are prepared to talk to us. And what happens, say, if, I don't know, China or Russia decides to put up a big constellation, how will we engage with it? Will it even be possible? So anyway, this center is supposed to bring those kind of people together, and astronomers and others. And there's one looking at, for example, community engagement, policy one I'm involved with as well. There's one actually observing them and trying to bring the data in together so we understand the problem properly. And if you're an amateur astronomer, for example, you can help with that. And then there's also one bringing industry in to say what is a realistic best practice and encouraging people to be open, because at the moment the problem is that I think, that a lot of it is seen as proprietary technology. So, you have to persuade the companies to want to share it. SpaceX have not been too bad about that. And another good example, which I would really like the UK to adopt, is this one, because we do have some powers beyond the treaty. And one of those is market access. The Effelsberg Agreement here is an example of how that was done in Germany, where they protected the German radio observatory at Effelsberg by saying to Starlink, if you want access to customers in Germany, you have to switch your beams off or not have them point at this observatory site. So that seemed like a really powerful tool, saying, well, actually, you want to have access to subscribers in a place like the UK, you can protect our radio astronomy sites. And we have some movement on that as well, I think. So some cause for optimism there. I think this would be a better model actually than trying to get something at a global level quickly, although I think we need that as well. So this is just a kind of radio map showing where they're not allowed to transmit and so on. And it's near the city of Düsseldorf, but it's a very well-established European radio site. In the UK, we have some moves around this, although it's a bit slow for my taste, but perhaps I'm impatient about these things. Last year, the Science Minister, George Freeman, is very big on space sustainability and trying to manage debris, actually. But we have tried to get him to include astronomy, and he did include that in a speech last year. Then, unfortunately, we had the massive chaos in the UK government, and he was no longer science minister for a while. And then there was another science minister who agreed to do it. And then a couple of weeks later, after Liz Truss, he was science minister again. So there's a bit of catching up to do, but it does seem as though he's still on board with it. And I keep phoning the attorney who's doing pro bono work on this to see where we're getting with it. We will obviously want to shape that with them if it happens, but we are still waiting for it. So look out for the space sustainability mark, as it might now be called. So anyway, to not dwell too long on this, what are we doing next? Well, we want to support this center. We want to support all these efforts. We are using our collective meager resources to try to help with this. We run working groups and so on. We really want to continue to talk to industry where we can. I think OneWeb is the best example for us because they're a UK part-owned company. And to my mind, having taken the decision to part by that company, the government can make them adhere to certain things. It was a very controversial decision. And I will mention the name Dominic Cummings to give you an idea of how controversial it was. But we want to continue to work with them in any case. Share that data. We're happy to make a positive case as well. If we see a company's doing well, we can say, look, actually, we recognize that you're making these efforts. Talk as well and give talks like this, and also talk to the press about it. And we had a conference back in January where we had a journalist there who reported really nicely on it, actually. And she wrote several stories about it. I think this kind of thing is probably the kind of thing that we're always going to get picked up by the press. But it's basically true. If you want to do things like detecting signals from deep space, then blocking them out with radio interference or making it harder to study the spectra of objects, the dispersed light of objects is one way of doing that. It does make it a bit harder. You could put alarmist things in there, like satellites stop us being aware of incoming asteroids or something, which is sort of true, but I'd be a bit cautious about it. But also, I think in the medium term, we need to think about, well, actually, I don't know whether this is the right approach, but thinking about, do we work with the environmental movement a bit more? Do we say, actually, look, there's a huge amount of stuff being put in space. It's very expensive. It's very carbon intensive to get it up there. And all we seem to do in many cases, which one level is good because it removes defunct objects, but do we really want to take all these incredibly valuable bits of equipment and metals and just burn them up in the atmosphere where they are obviously then beyond recovery? So, I do think that's something that needs to be considered. If we move to this model of having hundreds of thousands of satellites up there, then we need to be responsible about it. So anyway, so I hope I've deliberately tried to give you a quick kind of overview of all of this. You might ask what you can do if you're interested in helping. And the answer is, I think, bung off a letter to your MP. It's easy enough to do. Whether you get a reply or not, I'd be very interested to know. But why not? I mean, I think ask what the government's doing about it. There have been questions in Parliament and so on about this already. If you're an amateur astronomer, then observe the satellites, and there is a way of finding them. You can just put those basic, roughly how bright are they? Where were they in the sky? What do they look like? All of those things are not too hard to do. And most of the things I see are done with pairs of binoculars, even by professionals, actually, because it's quite hard to get telescope time to do this sort of stuff. They want to use it for the research they actually want to do. So by all means, do that too. But I think overall, I would want to give the message that I'm not absolutely pessimistic about it, but I am a bit, and I think we have to somehow collectively find a way to constrain this before it gets completely out of control. And we lose that view of the night sky forever. It will be very, very difficult to recover if we move to an economy where having hundreds of thousands of satellites, not all of which will be well designed, many of which will fail in any case, because that's inevitable. What do we do about that? Do we really think that the view of the night sky is so trivial that we can lose it forever in that way? So I'll leave you with that thought, and I would be very happy to take any questions. Thank you.
Have you looked at any research going on into ways of removing unwanted satellites? Is that something that's likely to play a significant part or not?
Well, I think the answer is that there are companies. There's Space Forge is doing that in the UK. There's an example of a company whose business model is exactly that. Interesting points around it are, I think that if you launch a satellite, you would think that when it went dead, it would be anybody would have the right to remove it. It turns out, from what I understand, that if, say, the UK launches a satellite, in theory, if another country removes it, they wouldn't really be allowed to without your express permission. So that's a complication. But also, I guess, as well, that if you're talking about such large numbers, it's really hard. Imagine trying to remove even 1,000 satellites of that 400,000 total, and how many missions you would need, and those are the big things. When you get down to the smaller bits of space debris, I'm not sure that there are good solutions possible yet to deal with that, because what is harder to manage is not just the stuff that's, large satellites or even things that have failed, it's the smaller bits of debris too. But yeah, I mean, I think to answer your question, it's obviously in my mind, but I'm not sure it's easy yet.
Robert, I have two questions online here. I'll read them both out. Where do you think we will be in 10 years' time on this? And another question, I hear some people say to resolve this, you just paint the satellites black, but obviously that's just a tiny solution. What other solutions are there?
Okay, so the first one, in 10 years' time, honestly, I don't know. I think there's a really large number of possibilities here. So we may have a situation where we've got, say, that 400,000 and more satellites, and possibly, and maybe there will be enormously difficult traffic management going on all the time, quite apart from the impact on astronomy, just to avoid collisions. Then, that's one possibility. Maybe they won't have mitigated anything for astronomy, and we'll be dealing with a very, very big problem and struggling, at least actually, with the public view of the sky as well. On the other hand, perhaps the companies will be better about it. Perhaps there will be, if not a treaty, at least international guidance that allows people to meet good practice guidelines, and national governments do, follow that model I suggested, where they say, well, if you want market access, you have to be a good player. That's possible. One of my, I guess, we don't know yet. But it's going to be, I suspect, somewhere between those things. The business model argument, I think, will stop it going to a very high end, because I'm not sure how much people will pay for access to these things and whether or not it will drive forward in quite the way they want. The cost of launching hundreds of thousands of satellites is not low. And if you want to do that, as some of the operators have said, will they get the revenue from around the world to pay for that or not? I don't know. Even SpaceX, I think, has to have 100-odd million users to make money. That's a lot. You know, there's a lot of people. I don't think there's any internet provider, even in the US, that would do quite that well. And they would be the ground-based ones are a lot cheaper. It's not that cheap at the moment. And the other one, Phil, sorry, was oh yeah,
technical
yeah.
solution to paint the satellites black, and are there any other solutions?
Well, actually, so SpaceX had something called DarkSat at the start, where they did just that. And the problem was that the satellites heated up because, you know, you paint something black, it gets hot. So they stopped that. Then they had a visor system whereby they had this, well, basically something that would shield the satellite that wasn't on it so that the light reflected. They had to change that because it wasn't hot. The satellites communicate with each other with optical systems, lasers, I think. And so they were getting in the way of that. Then they've moved back to another different kind of dark coating with less of a heating effect. So it is actually that kind of thing that people look at, that we try to encourage, and generally making sure that they model the shape of them and so on, so we understand how much light they'll reflect.
I think you touched on the solution. Listen to me. It's going to be commercial. You can talk about hiding the sky and no one will care. Let me be crude. If you were to say, oh dear, the satellite navigation won't work unless we do. Oh, I understand that. Seeing the sky or not seeing the sky is neither here nor there. But the commercial solution, Elon Musk and others say, it's a waste of time putting up anymore because we're not making any money out of it. Is that not?
It might be. To answer, yeah, who knows? Will it be that the failure of the commercial model is why this doesn't happen? Perhaps. I guess. I mean, people are signing up to Starlink. So there's some revenue. I mean, even people in the UK in rural areas where they've got terrible broadband connections are doing it. So there will be some customers. And even when I was talking, one of the reasons I was saying actually that, you know, indigenous communities, you can't make assumptions about. It's ridiculous to say everybody thinks the same way, because some remote communities in the US, for example, have signed up too. But, you know, it's really hard to say. Maybe you're right, that will stop it. My worry is that if the companies go bust, that you're still left with all this stuff up there and they're no longer controlling it. And it becomes the responsibility of governments. But will it be the most pressing thing? I doubt it. So, you know, we need whatever happens with this, we have to have an end of life protocol. A lot of that might mean burning it up, which isn't great either, because then, you know, you're losing all these resources. But perhaps, I mean, I'm not suggesting I want these companies to go bust. You know, they're doing other things, good people working for them, etc. But I mean, I suppose maybe if one of the big ones failed, then the others might take a second think about it and say, do we really want to follow this model or not? I don't know. But you make a fair point. And you're also, I think it's quite, I'm well aware of the fact that arguing for a good night sky on these grounds alone is hard. I mean, it's a bit second order, but there are, for example, impacts on biodiversity as well and so on, because things like particular insects and birds and so on appear to use the night sky to navigate. So if we interfere with that, what does that do for biodiversity as well? But I think the research on that is it's not that well established yet. People have tried things like put insects in planetaria and that thing and see what happens if you move the stars around. It does seem to affect them. And again, that would be, I suppose, a kind of, you know, arguing for that precautionary principle where we say, well, should we worry about that too? But, you know, you're right in the sense that if I was to stand here and say pristine night sky or brilliant global internet access, I'm well aware of how that argument would go, but we will nonetheless try and make the point. And I don't think those two things are entirely incompatible.
We have another couple of questions online, Robert. How would you compare the issues caused by satellite proliferation with the issue of increasing light pollution, making the night sky too bright? What is the bigger issue? Another question, if we do nothing and no more satellites are sent up, how long will it take for most of these low Earth orbit satellites to fall to Earth?
Okay, I'll come to the second one first. The second one, I think the answer is several hundred years. And that's based on presentations I've seen where we talk about how long, where the authors rather talked about how long it takes for the material to decay. So that sort of time scale, you know, wouldn't be trivial. You can't, in many cases, it depends on the altitude. The OneWeb ones would take a lot longer than the ones lower down, the SpaceX ones. In terms of one or the other on light pollution on the ground, well, I think they're both issues, aren't they? I mean, light pollution is much more visible to us quite clearly. If and has a much more direct impact on us. So if you live in a place and you've got very bright streetlights outside your bedroom, it interferes with your sleep. And if you're inside the house, this doesn't do that in the same way. However, I would argue that if you're in a place you expected to be dark, so imagine you go to the Atacama Desert, one of the darkest places on land on Earth, at least on land on Earth, and you still don't get a good view of the sky, then that's deeply unfortunate. If you see the sky as part of our cultural heritage, human heritage, a part of the natural environment, and there is nowhere on Earth where you can see it in its pristine state, I think that's deeply, deeply unfortunate. And, it's a huge tragedy. It's, we ought to be able to protect that humanity. And I'm not saying you can protect it everywhere all at the time, but access to that is really important.
To thank Robert for that very interesting and expert survey of what's going wrong with our night sky. Do look out for any policy announcements from the Royal Astronomical Society, which Robert will be behind. So I would like us to thank Robert for the talk. Thank you. And to thank you all again for coming, and we look forward to seeing you back at the Royal Astronomical Society for the next public.
Yeah, there is one next month. I can't remember the title, but it'll be much more upbeat as well. So, but thank you for coming and finding out more.
Thank you.